So this is the question video for the estimation accuracy and rounding video. So in the previous video we did the theory. Now we will do the practice. I will attempt any 3 questions, okay, just so you guys can get an idea of how they work, and then you guys will do the remaining thing. Before that, you guys can just copy note down the questions on the screen. Just pause the video and note it down. It's like a bunch of questions I found, which I don't know if it's like a appropriate or proportional amount to do those questions. We will see. Okay. I will also explain why some questions I have marked it non-calculator and some calculator. Okay, because this chapter is a bit controversial in terms of calc and non-calc papers. That's why I have some inconsistency with the thingy. Let's start doing them. Okay, write these numbers in order starting with the smallest. Now, when I was finding questions for this chapter, all of them required a calculator. Basically all of them. Okay, even the ones I marked non-calculated, they still need a calculator. Yeah, that's a scam. So this is because of the IGCSE past papers. I can't blame them. No, I will blame them. Yes, because they didn't do non-calculator. So that's why. If you guys want, I can make this thingy again, but with 4024, which had non-calculator from the start. Okay, so I think I may make a following video for this chapter, because it's like very important that you guys learn how to convert numbers into their magnitudes without a calculator. Okay, it is very crucial for a proper development of your understanding of the subject. Well, unfortunately I just have to use my calculator. Write these numbers in order starting with the smallest. This is easy. This is 0.58 and 0.574. 11 over 19 we have 0.5789. Okay, I did like one more decimal just to be sure. 27 over 47 you got 0.574. Now I do not have enough answer space, so forgive me on this, but let's look at the answer. Look at these carefully and deduce our answer. Well, how do we know which one is bigger, which one is larger? I had one of my friends have difficulty in ordering one time. So if he is watching in the future for the preparation of mathematics, then how do we order it? I want you to look at every decimal place individually, then look at the magnitude and then order it. Okay, now this is from smallest. Okay, start from the smallest. Now let's look at the first digit, 0, 0, 0, 0, nothing special. Second digit, 5, 5, 5, 5, nothing special. Third digit, 7, 8, 7877. 7877. Now, because of, okay, now you are going to read the digits from left to right. If there's the larger digit, okay, the larger digit will be ranked this way. Okay, so since this is larger, we will have 58% as our largest number, and we can then go on. The fourth digit is 844. Now here this is the largest number, so this is in second place, 11 or 9. Next, the other digit. This is the same. These are the same, so we need more decimal for this. 27 over 47. This is 7544. Now this is 4 and this is 0. This is higher. So this is 27 or 47, and our final value is 0.574. Perfect. Right? So this is our, oh god. So this is our ordering. Pretty cool. Oh, I didn't pick up all of the digits. Yes. So I'll just keep it over here. Next, m is a positive integer. Write these values in order, starting with the smallest. Now, in order. So we have 4 digits values, and we have to write them in order. Now, they are in terms of m. So we can think of m as 1. Simplify everything. So this is 1. 33% of 1, meaning 33 over 100 times 1 is equals to 0.33. 1/3 of m, meaning 0.33333 times m times 1, meaning this number. 320% of 1 over a tenth. So 320 over 100 times 1 over a tenth. 0.32. What a nice number. Now all of them are obviously in terms of n. M. But since we, m is 1, like we stated earlier, we will just ignore it. Now let's look at the place values. First digit 1000. So this is the first place. Second 333. So this nothing special. Third 332. Ooh. Now this means this number will be smaller than these two. We can put this in the end. 320% of m over a tenth, and you can ignore this. Now the next digit, this is 0 and this is 3, meaning this is in here, 1/3 of m, and the last one 33% of m. Very cool. I hope you guys understand how I'm doing this. Starting with the smallest. 1, 2, 3, 4, 5. 5 over 8. I get 0.625. 11 over 12. 0.9166. 2 over 3 we get 0.6666. 3 over 4 we get 0.75. 13 over 24 we get 0.5416, and repeat it. Now this is a bit better question. It has variety. Let me do this last one again. Okay, next. The first digit 0, all of them are 0, so nothing special. Second, we have 6, 9, 6, 7, 5. So this is the least, and so we will put this in here. Next digit, 6, 9, 6, 7. Now this is the second other placing. The both 6 values, these both values 5 over 8 and 2 over 3 will be in their respective positions, so we can ignore them. 7 will be in this position, 3 over 4, and 9 will be in this position, 11 over 12, because this is the highest value. Next, look at the other digit of these two. This is 2 and this is 6. So it makes sense that this will come before this. Boom, very easy, very quickly. Nice. Now I hope you guys can do it yourselves. Yeah, for this, just convert them into 1 unit, like I suggest centimeter or a meter, depending on which SI units system you use, SI or CGS, I think that's the name. Use a calculator for now. You will do it when we are in standard form chapter. Negatives are at the very last. Okay, if all of them are positive, then the negative will be negative. Okay, you can use a place value to illustrate your answers as well, if that makes it a bit easier for you guys. Okay, whatever method you are taught or is easy for you, repeating decimal notation, so you can use that as well. And then we got these types of questions. Now remember what I told you, ordering. Okay, we use these symbols to bound numbers, right? So this is like an example how we bound numbers, and we can also use them to compare two numbers also. So you guys can do this yourselves. I will just do one of the exercises. Example, 2 over 3 is smaller than 0.667, because this is 0.6666 repeating, but this ends in a 7, so this value is larger, and hence you can place this over here, because 7070 is larger than 66, and so on. If you add more values, so on. I guess I hope you guys can understand. Product of two numbers. Now you have to be very smart about this. I do not want you to waste your time doing like every computation, every pair. So you have to be a little smart about this. I want you guys to time how long does it take to figure out the answers. Okay, I'm not giving guys the marks. Estimation. How do we do estimation? Well, the 2 marks are special. Okay, one is to show that you are what values you are transforming them into. Next is the answer itself. Now all of these are non-calculator, so I will obviously not use a calculator because they're quite easy. I think so. Even for non-calc. Okay, I hope everything is computable, like doable without a calculator. Let's find now. Correct to one significant figure. Let's convert them to one significant figure. 5.3 becomes 5, 19.5 becomes 20, and 2.49 becomes 2. I hope you guys can understand. Next we have 5 times 20, 1 over 2. We get 50 as the answer. Very cool. 62.5 becomes 60, 9.7 becomes 10, and 0.52 becomes 0.5. 60 over 10 times 0.5, we get 60 over 2 is equal to 30. Nice. 42.8 becomes 40. 17.4 becomes 20. 1.97 becomes 2. And I don't have any answer space, that's why. But you guys can write it in like nice line form when you're working, blah blah blah. And 5.79 becomes 6. So you got 40 plus 20 all over 2 times 6. We get 60 over 12, 2 times 6. This is 10 is equals to 5. Nice. I hope you guys can do the remaining questions. Yeah, very easy. They are very easy. Don't worry. If you guys cannot solve them without a calculator, like having some decimal issues, then go for using a calculator. Okay. But make sure to try to not use a calculator before you do use a calculator. Okay. Now, rounding the answer is a mandatory step. You cannot skip this. Okay. Rounding. How do you do rounding? You guys know how to do a rounding. Please send me. Nearest 10. I will do a few of these questions, like 3. Then you guys can do the remaining 15 or so parts. Nearest 10. So this is 8, 4, 50. 10, 7, 170. Be careful. Okay, be careful. 15, 900. Okay, 15, 900. Very good. Now, some might say, no, you are lying. You did it to the nearest 100. I will get to this in a second. Okay. Before that, let's do our thinking. But keep this in mind. I left out in the last video that you cannot be certain for some values that did he round it up to this or up to this. Okay, that's why I said in the significant figures that the zeros after the decimal point and before the non-zero in the integer part, you cannot be certain which zeros are significant or not. Okay. To the nearest 100, 50 to 100, nearest 100, a shameful 8500 and this 6500. Correct to the nearest 1000. Now some of these values are from by me, so have fun, you past paper addicts, finding them. 16,000. This is 10,000. Yes, we have it up value. Very weird, I know. You may get like insane numbers also. I spammed my keyboard and call it a day. 1 decimal please. Very easy. This is 556.2. I barely have any answer space. That's like a very bad habit of mine. I do not know how much answer space to give. That's why I do it. 16 point. This is 17. In it, two decimal place. 1426.31. If you guys can see this answer, then okay, I'll just put it outside if you guys want. Two decimal places, 16.009, and three decimal places, example 3.722. Nice, very simple. To two significant figures, 1, 2. Remember, use your significant figure rules. This is 0.047, 330. Now the remaining values, it's okay, you guys can write it, but it is generally not important. Okay, two significant figures, 57 1000. Okay, remember after the decimal. Before the decimal, it's, yeah, you got to write it, please, come on. But after the decimal, it's okay if you do not include it. To 3 significant, this is this 6.82, and now we'll do it like here, 0.00386. Find the value of root 15 to the, like, these use calculator. Okay, these use calculator, so you guys may need to write them into calculator. To the nearest integer, meaning to the nearest whole. Okay, 67. Say no. Now, I told you earlier in this part of the video, you cannot be certain at what place value I rounded my answer to. Here, this is the same thing. Tanvi rounds the number 4896. She writes down 4900. Rahul says that Tanvi rounded 4896 here to the nearest 100. Explain why he cannot be certain that she rounded the number correct to the nearest 100. Why? Because 10 can give the correct answer also. This the same answer, not the correct answer, the same answer. And rounding, yeah, this rounding this or this can both give the same answer. That's why Rahul cannot be certain that the number that Tanvi rounded is rounded to the nearest 100. I hope you guys can understand what I mean. What I'm trying to say is that both possibilities give the same answer. Okay, but you cannot be certain which one of the two you chose, because both are the same thing. So this is why Rahul cannot be certain, and we cannot be certain about the significance of these two zeros. Hence why I say that these two should not be counted as significant, because they are, they make you be in doubt. Okay, that's it. Yeah, just take that for granted. We can do like a big proof, but proofs are not in the syllabus. We'll see. Let's do these, one of these, 1.47 to the 3. Now some I will likely put them in using a calculator question, so be mindful of that. So this is 3.1765 blah 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 to 3, correct to 3 decimal places. So this is 3.177. done. Very simple. You guys can do the rest, I hope. Limits of accuracy. This is the final thing before I end the video. Now this breaks in two parts. One for the core students and the extended students. That if you're doing core, then these questions are most expected. If you're doing extended, both questions are expected. So if you're extended, you may do core. Okay, you may do core for building your core, but if you are normal core, I don't know, I am laughing, then you may only do these questions. Okay, because doing working with upper bound and lower bound isn't in the syllabus of the core syllabus, but extended syllabus got to do the extended questions also. Okay, I'm sorry, it's just the way it is. Sometimes you may have to use the calculator, I have not looked at this properly, but you may sometimes come into issue of using a calculator. Okay, if you guys cannot do decimal addition subtraction correctly, okay, you may try without a calculator, but I suggest using a calculator. Okay, because limits of accuracy, I've seen them usually come in calculator papers. That's why. Okay, so if you guys want to still build up your non-calculator ness, I guess you guys can say that, then sure. The distance m between town P and Q is 97 kilometers, correct to the nearest kilometer. This statement is the accuracy, which is 1 kilometer. What is the upper bound? Now we write lower LB and UB. Lower bound of D is 97 plus a half of this. Half of 1 is a half, so 97 minus a half is what? 96.5 plus a half, 97.5. Very easy. 28.5 tons, correct to one decimal place. This is our accuracy. Correct to one decimal place. 1 over 2 is equals to what? 0.05. So our accuracy is 0.05. 28.5 minus 0.05, we got 28.45 and 28.55. Recheck your answers with calculator if you're doing without a calculator. Okay, see, I almost messed up. Traces this correctly to the nearest kilometer, meaning 1. So 1569 minus a half, 1568.5, 1569.5, 1569 plus a half, and so on. I hope you guys can do the remaining exercises that I have assigned to you guys. Like, it's pretty repetitive. Okay, I do not mind if you guys do less of them. I hope you guys can do this. Okay, just use your understanding how this works. If you guys want, you can get like potatoes and carrots masses, then compare it, if you guys are students, you understand by doing it practically. Extended. Okay, if you guys are core, then goodbye, and like and subscribe and share and have fun. If you are extended, stay in here. Let's do some of these questions and see how they work. Okay, I have made some diagrams again by myself. Yes, I should not have put myself through this, but yeah, it's fun. Okay, it's fun doing all this quote torture. Let's go. Nina walks an average speed of 5 kilometers an hour, correct to the nearest kilometer, meaning 1. Nearest is 1. She walks for exactly 2 hours. Work out the lower bound for the distance Nina walks. Now, the speed has an, is a variable. Okay, it's like an approximation. So we can think of this as like about 5 kilometers. And she walks for exactly 2 hours. Now, this is a constant. Okay, this is not like around 2 hours. This is exactly 2 hours. So, how do you find the distance? So, this is kilometers an hour times an hour is equal to a kilometer. What's a kilometer? So, lower bound. Lower bound was what? Is equal to A of B times B of B times blah blah blah. X of B. Yeah. Oh god, I forgot my own convention. Now, ours is a constant, so we can just keep it a constant. 5 is not a constant, it is a variable. Okay, we know the accuracy of 5. Lower bound will be just subtracting the accuracy, so this is 5 minus a half, this is 4.5, this gives us 9. So this is the lower bound of her speed. Okay, it may ask for both the bounds also. We will look at this. Let's look at this. Jenna has a length of a wire measuring 86 centimeters, 20 centimeter. From this wire, she cuts off two smaller pieces. One, a piece of length of 47 centimeters, calculated in millimeter, and this same. Okay, now I want to keep the units same. Why? Okay, before that, let's look at this. Work out the upper bound and the lower bound for the length of the wire remaining. Now, we may give it as a centimeter or as a millimeter. I like centimeters because that's what I generally am comfortable with. So, millimeter to centimeter, what is it? There are 10 millimeters, make a centimeter. So, we do 4 nearest millimeter or the nearest 0.1 centimeter. This is our accuracy. You guys can read my handwriting then, okay. So, how do you find the upper bound and lower bound? Now, there is a wire of 68 centimeters and there are two small pieces, 4.7 and 10.0. You want to find the remaining. So how do you do it? 68 minus 4.7 minus 10. Right? Correct? But you want to find the upper bound and lower bound of values. So let's do it. X of lower bound is equals to A of upper bound minus B of lower bound minus C of lower bound, blah 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 blah. So the upper bound of the what? Total 68, which is to the nearest centimeter. So find the upper bound, which is 68.5. Lower bound of the second value, let's take it 47. Now, meaning we have to do 47, 4.7 minus 0.1 over 2 or minus 0.05. Let's do a calculator. 4.7 minus 0.05. This is 4.65. And C of L. 10 minus 0.1 over 2. 10 minus 0.1. Fraction 2. We get 9.95. And so we get the value 68.5 minus 4.65 minus 9.95. We get 53.9. Very simple. Now the upper bound. How do you find the upper bound? It's simple. X of u is equals to x of lower bound minus x of upper bound minus C of upper bound. Okay, I heard you guys screaming. This is wrong. This is the first bound is same. Sorry. Dot 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 dot. I was so confident. 67.5. Bound of upper 47. 4.7 plus 0.1 over 2. We get 4.75. And 10 plus 0.1, we get 10.05. Now this should be the correct value. 67.5 minus 4.75 minus 10.05, we get 52.7. Nice. 52.7. Now we have the correct answer. Now the upper bound, it is x of u is equals to a of u minus b of l minus c of l minus dot dot dot. Now we have two values, so that's A of u, what is this? 68.5. B of L, 47. 4.7 minus 0.1 over 2 is equal to 4.65. And this is what? 9.95. We get the value 68.5 minus 4.65 minus 9.95. 53.9. Nice. 53. Now it looks correct. Yay. And let's do a third question. A metal cube has the mass of 4.2 grams calculated in correct to one decimal place. The lower bound of the mass of the cube. So this is 14.2 minus 0.1 over 2 is equals to 14.15, right? The side length of the cube is 1.3 centimeters. Right to the 0.1 decimal place. Calculate the upper bound of the density of the material, of the metal. Density, we know density. Let's do this. Now, what is the volume of the cube? Correct? It is 1.3 cubed. What is this? Okay, first let's define what we want to find. Density, upper bound of the density. D of u is equals to mass m of u all over v of lower bound. Then mass of upper bound, we know the upper bound of the mass. What is this? 14.2 plus 0.1 over 2, we get 14.25. Volume of lower, how do you find this? Very easy. What is volume? Length cubed. What is cube? Length times length times length. Now, multiplication, the lower bound is on. So this is L of lower bound cubed. So what is this? 1.3 lower bound is equals to 1.25 cubed, which is 1.953. 3 decimal places. Take it to 3 decimal places. Now this is your working. So D of u is equals to 14.25 divided by 1.953 is equals to what? 7.296. Now in upper bound and lower bound, leaving your answer, okay, not rounding your answer is actually better. Yes, you should not round your answer. I use 3 decimal places. It's okay, just leave it in 3 decimal places. What's wrong with that? We do not have to round our answer in upper bound and lower, in limits of accuracy. Okay. Whenever you are doing estimation, accuracy and rounding, in limits of accuracy, yes, this chapter, limits of accuracy, you do not have to round. Remember, no rounding. Okay, yeah, I hope you guys can understand this. Okay, if you guys have any issues, you may comment down below. I hope you guys got many questions to practice from. If you guys were practicing already, then good, well and good. Okay, like, subscribe and share, and see you later.